The topic for today is to factor expressions. I'm going to write the topic in here so you can see it better. Then in the example one, we need to factor expressions. Then we have the example that says, Kiana painted a rectangular wall blue to start an ocean mural. She used 3 cans of paint, each of which covered X square meters, and a different size can that covered 12 square meters. What are possible length and height dimensions of Kiana's mural? Okay, you know that each can covers a number of square meters, but we don't know exactly how many square meters, so we can use a variable to represent this. We are going to use the variable x to represent the number of meters that the can cover, okay? The 3 can, because there are 3 can of paint. And we have for the other part, another can of paint, but in this one you know that covers 12 square meters. They give you information about the 12 square meters. Okay, one way to solve this is to use an area model to represent the area of the mural. We have the equation 3x plus 12. I'm going to write the equation. What represents this equation 3x plus 12? 3 can of paint, x is the number of meters that they are going to cover, and the number 12 is the number of meters for the other can of paint. Remember that you have other can, that it's 12. Now, one way to solve this is to use an area model. It's the diagram you have below. In this diagram, you have 3x in the blue part and the 12 in the green part. 3x again is the 3 can of paint. X is the number of meters that they are going to cover, and the 12 is for the can of paint that we have additional. So one possible set of dimensions of the mural could be x plus 4 meters long and 3x meters tall. Okay, and how can we need to factor this. Then go to the part to the right, another way, to see how to factor this. We can use a common factor and the distributive property to factor the expression. A common factor is one factor that we are going to have in both terms. It's something in common, okay? That's the origin of the name. It's something that it's one factor that I have in common in both terms. It could be more than 2 terms, okay? But in this case, I have 2. So I need to find the factor. If I have this expression, 3x plus 12, what is the other thing that I need to do? 3x plus, and I need to separate the number 12. I need to separate the 12 in 2 numbers that multiply are going to be equal 12. And one of the numbers that you are going to multiply is the number 3. Because remember, I need to have something in common, so I'm going to use the number 3. And what number I'm going to use to multiply this? The number 4. Because 3 times 4 is going to be equal 12, okay? So 3x plus 3 times 4, that is going to be 12. I have the common factor now. And what can I do to solve this? I'm going to start taking the number, okay? So if I take the number 3, I multiply this outside the parentheses, and inside the parentheses I have x, because 3 times x is 3x. plus 4. You can see I take the number that is the same and I write it outside the parentheses. And this is the expression that we obtain when we factor this expression, because 3 times x is 3x and 3 times 4 is 12. So this is the factor of this expression. The number 3 is the factor of this expression. Maybe we can try the other one, the exercise that says try it, so you can have more clear. Use factoring to write an expression for the length of the pool with the given width, 4x plus 20. So what can I do to simplify this? Remember, in the first term, I only take the number with the variable, 4x. Plus, I need two numbers that multiply are going to be equal to 20. But remember, one of these numbers has to be the first one I have, because I need to have the common factor. So 4 times 5, because if you multiply 4 times 5, you obtain 20. So now I take the common factor and I'm going to write it outside the parentheses. 4x plus 5. 4 times x is 4x and 4 times 5 is 20. Okay, so you can see that if you use the distributive property is the one that says that if you have one number outside the parentheses, you multiply it by all the numbers inside the parentheses. Okay, so not literally what it says, okay, but in the practice, that is what we do with the distributive property. Okay, then in the example number 2, we need to factor expressions with negative coefficients. Okay, Rodrigo and Jordan each factor the expression negative 2x minus 6. And we need to know who factored the expression correctly, okay? Which one of them factored the expression in the correct way. Rodrigo uses a positive common factor to factor the expression. So we are going to do it one by one. And for Rodrigo wants to factor this expression. Negative 2x minus two numbers that multiplied are going to be equal 6. It's going to be 2 and 3. 2 times 3 is 6, right? Okay, and I have the negative sign in here. And again, what I'm going to do, I'm going to take the number, in this case the number that it's in common, that it's in both terms, and I'm going to write it inside the parentheses. But remember, they use a positive sign. Rodrigo uses a positive number. So 2 times negative x, because the negative is going to pass to the x, minus 3. This is what we have for Rodrigo, because Rodrigo is factoring the expression, but the factor he takes is the positive 2. And now I'm going to work with Jordan. What is the Jordan form? Jordan uses a negative sign. So if you have the expression negative 2x minus 2 times 3, if Jordan use the negative, I have this. Negative 2x is the factor that I'm going to take. Negative 2x. Look that the only difference is the sign. X is inside the parentheses and the plus 3 is inside the parentheses too. I use the distributive property, and 2 times x is 2x and 2 times 3 is 6, okay? only that the 6 is negative and the 2x is negative. I have the negative in here outside. The same for Rodrigo. If you multiply, you are going to obtain exactly the same result. So we can say that both of them are correct, okay? Rodrigo and Jordan are correct. Rodrigo and Jordan are correct. So both of them are correct in the way they factor the expression. The difference is that one of them uses negative numbers and the other one uses the positive one, okay? That's the only difference that you have in here and in here. But remember, when you multiply, you are going to obtain the same because the sign is going to be negative. In the example 3, we have to factor three-term expression. Factor three-term expressions. Now, what can we do in the example 3 that we have 6x minus 18 minus 2y. What can I do in here? 12, sorry. I need to factor this. I need to factor all the three terms to find the expression that I'm going to use. I need to find the greatest common factor. That is the GCF that you have on the book. I'm going to use the greatest common factor for all these numbers, okay? The greatest number that we are going to obtain, that it's in all the terms, okay? That it's a common factor. Common factor is something that they have in common, okay? So the step 1 is to find the greatest common factor. So the factors of 6, the first number we have is the 6. The factors of 6, the factors of 18, factors of 18, and the factors of 12. Okay, what are the factors of 6? The factors of these numbers are going to be the numbers that you can use to divide the number, okay? And you are going to obtain an exact division, okay? The factors of 6, for example, remember that all the numbers can be divided by 1, so I can write the number 1. I can divide the 6 by 2. Can I divide the 6 by 3? Yes. By 4, no. By 5, no. By 6, yes, because you can divide all the numbers by itself, remember. You can divide it by 1 or by the number itself, so I include the same number, 6. Now, the factors for 18, I'm going to complete with the factors for 18. 1, I can divide by 2, I can divide by 3, I can divide by 6, I can divide by 9, and I can divide by the number itself by the 18, okay? 18 divided by 18 is 1, 18 divided by 9, 18 divided by 6, okay? In all of them, you obtain a exact division. Now, I only need to write the factors of 12. The first factor is the number 1, 2, 3, but we include the number 4, 6, and the number 12. 3, 4, 6, and 12, okay. Then, what is going to be the greatest common factor? The greatest common factor is 1. It's in common in all the terms, but it's not the greatest. 2 is in all the terms, but it's not the greatest one. 3 is in all the terms, but it's not the greatest. 4 is only in this term, so it's not 4. 6 is in all the terms, and it's the greater because 6 is greater than 3, is greater than 2, and 6 is greater than 1. So the greatest common factor again, is the factor that I have in all the terms and it's the greatest one of them, okay? So the greatest common factor is 6. The only thing that we need to do to complete this, now I know the greatest common factor is the 6. So if I have the expression 6x minus 18 minus 12y, then I simplify. I'm going to move this a little bit. Okay. Greatest common factor is 6, so I'm going to take out the greatest common factor. 6 times x minus 6 times 3 minus 6 times 2y. 6 times x is 6x. 6 times 3 is 18. And 6 times 2y is 12y. Look that they are negative, okay? They are negative. Then, the only thing that I need to complete is to take the greatest common factor. The greatest common factor is 6, and I write the numbers in the way I have it. X minus 3 minus 2y. Okay, because if I eliminate the 6 in here, for example, you have negative 3. If I take away the negative 6, you have negative 2y. So this is the factor expression we obtain. 6 times x minus 3 minus 2y. This is the factor expression, so the only thing that it's new for you, maybe it's this. The part when you take the factors, okay? But in the other part is the same. Only to use the distributive property, or in this case, for example, only to take the common factor out of the parentheses. So I think that I'm going to finish in here, guys. I'm going to finish in here.